So as I mentioned today, we're going to be talking about creating IoT devices tomorrow. So into a kind of a introduction of who your speaker is going to be and what's going on in the market. So what challenges and opportunities that exist within the IoT market. Jump into some of the key aspects to keep in mind when designing an IoT device. So whether it's hardware, that hardware plays with software and graphics, and then key GUI development capabilities that really help optimize the development of the UI for the IoT device. What resources can be really leveraged within NXP's embedded systems by our development tool called Storyboard. And then at least we'll jump into the question and answer. So we're very lucky today to have two great speakers. The first is going to be Rob Cosaro. He is the IoT Technology Officer at NXP. And we also have Jason Clark, who is a co-founder of Crank Software and is the VP of Sales and Marketing. So with that being said, let's jump right into it. We're going to be kicking things off, graphics for the IoT market, and really kind of you an overview of what's really happening in the world. So I'm going to be passing things over to you, Rob. So while he's digging up the presentation, keep in mind, Rob, you muted your microphone, so you may need to come off mute.
Thanks. Yeah, sorry, I'm having a little problem with the internet, as always. Let's see, let me show my screen. Okay, great. Can you see my screen, guys?
Can see, yes, we can see your PowerPoint, just mode and you're
perfect. Thanks. What I want to talk about today is give you a first of all of kind of market. I think this is something that is always an evolving topic, but off with mainframes, then muters, then personal computing, and mobile computing kind of forefront
just to let you know, just seeing if we're only seeing your PowerPoint, you're not your in presence, you just need to switch over to
You're not seeing?
No, I can share from my end, and we can kind of, you just tell me which one when to flip. Does that work for you? Okay, we'll do that.
Yeah, that's fine. Go ahead then.
All right, I'm sharing the first slide, the fifth wave of computing right now.
Okay, great. So let me start again. So the idea that computers have gone believe that. But one of the biggest things right now that we're seeing in our this idea of IoT. IoT is a big word, and really anything that's connected to the internet. So anything from a washing machine to a hair dryer, and that now becomes an IoT device. So the market kind of expands depending on what you have connected to it. So I always think that's kind of funny. But anyway, this market is growing significantly, and you're seeing those kind of in your home every day. Slide, please. So the other thing that's changing is that you're seeing a lot more horsepower in your home. So there's a lot, we call that the empowered edge. So there's, instead of everything go to the cloud, you'll have the idea that there will be more things connected to a server. You reduce the amount of latency, also all other kinds of issues. So compute that's going to be in the environment is increasing significantly. And I think that's something to keep in, that's really important as far as what's going to be in the future, especially with products that you guys are on. Next slide, please. So this slide talks about this idea of intelligent pyramid, where you have these large data centers, which is not a huge amount, of those around, but they're significant. And then there's the edge devices, and those are going to expand significantly, we believe. And at the bottom, there'll be billions of these edge devices. You're already seeing that. You know, in my house right now today, I have a vacuum cleaner. Believe it or not, I have my thermostat. I have my Alexa device. And 5 years ago, I wouldn't have thought that I would own any of those things, but I find them useful and worthwhile to have in my home. And I think there's more things that are going to happen in that space. So the idea of having those things and being able to use those effectively needs these kind of intelligent network edge devices as well. Okay, next slide. Yeah, thanks. As I talked before, you'll have personal devices, as well as there's the smart appliances, and I think the smart that's changing too. It's not just it's more about maintenance and things like that, and we're changes in that for sure. So emerging consumer spaces, there's a lot of things here for smart tags, other devices looking at even shipping, smart shipping containers. Next slide. So I think this is familiar with, you know, what's happening in your house. Smart sensors can look at temperature, smoke, all kinds of, like I said before, thermostats are becoming more. I have a Nest house, and I think that's the thing. I really enjoy having that. And the idea of having smart and things that turn off and on, you know, door locks, security cameras. If you look at what was just announced by Amazon last week, you know, the drone that are out with the camera. That's interesting. Some of them may be bad, I'm not sure. So all that works out. You know, the market will decide what's good and what's bad. But I think in general, I see a lot more of these smart. It's not smart. I overused word, but this things that make life easier. You know, trying to help menial tasks and trying to look at what's repetitive and how I can, you know, eliminate some of those kind of ideas. Next slide, please. So always this idea of silicon, you know, I'll give you a wearable example. We've been working on these for a while, but, you know, battery life is a good idea there, where and you want to be able to have a small form factor where the batteries are small. You can't have a large battery on your wrist, as an example. And also this idea of having a small thermal footprint as well, because on your wrist, the temperature increase you can feel. So those kind of things are really pushing lower and lower power in our devices. And graphics is always an important part of that user experience, and how do we get low power graphics on your wrist or in any other area that needs low power ideas. And I think one thing I just want to also say, there is a trend too in the home right now that the idea that an always listening device drawing a fair amount of power is causing concerns within governments. So you're going to see like Energy Star things happening with those kind of devices too. So we're seeing a lot of emphasis on lower and lower power, especially during standby. So that's something that we're working to reduce consumption of all of our devices. Okay, next please. Okay, so I think I always find this idea of process and how that affects what you're. So density is still increasing on the bottom. So you look at the different process nodes over 2000 to today, which is you're moving to 5, and the density still. Look at these. If you look at these products, if you look at the die size, they're pretty much this. They really haven't shrunk anything. It's like they look very much similar. But the thing that's added is features. It's the things that you can do with these things tremendously, and that's the engineer's life's difficult. We can put a lot of things down on silicon, but then use those things. And I think that point I want to get across in this webinar is that we're putting a lot of stuff down in silicon and having a crank software that can manage of all the things that we're doing, because no way that you can figure out how to use it. You have somebody that has detailed knowledge of that, and having a ground like crank really invaluable. So anyway, density still, we're never going to get away from that. The idea that non-memory is still there. Important part of what we do as far as microcontrollers. So floating and non-volatile, 40 nanometer is the last, at least what we'll use. There are some ideas that you'll see cells in 28, but I don't know if we'll ever use that. Our alternative NV memory now, like MRAM, RRAM, and we've been looking at MRAM 28 nanometer and also moving that in. So we taped out using those. Yeah, I think internet's a little bit slow. Next slide. Yeah, great, thanks. Okay, thanks. So I just wanted to show how this process is kind of affecting our products. And our stuff is, the stuff that we build is available in the general market. So it's available to everybody. So we introduced the LP5500 series in 2019 that uses 40 nanometer flash. And we just introduced RT500, RT600 that are in 28 FDSOI, and we announced an 1170, which is also in 28 nanometer. We have an item 8M, which is in 14. And I just wanted to show this of where we're at and where, as an example, Apple sat with their processors. So the general market, so it's something that you have to take into account on looking at what you can use in products in the general market. So now today, we are offering 20 nanometer devices and also 14 nanometer devices. And what does that mean? It's like, yeah, we talks about that, oh, we're going to get 4 nanometer one day or 1 nanometer. I think the idea is it allows us to put a lot more things to product than were available before. I'll give you an example. M33 is about 300 to 400K depending on the implementation that you have. And in 28 now, that's about 0.1 to 0.2 square meters. So adding cores and logic into these process nodes is not an expensive proposition. So you're going to see a lot more features coming in our products, and I'll talk about that next. Okay, next slide, please. When I started NXP, that was in about 1999, and I'm 85, and we moving on ARM processors, and we had displays was like the biggest thing back then. We had 88 faces, and it was relatively easy with those. And then later on, we said, oh, we're going to add graphics to our parts. I mean, that's very hard. So we used, and graphics was like that. It was like, oh, what do we do for graphics? CL110, 111 were just simple controllers. And that was our graphic story back then. And it had RGB interfaces. CL111 had some cursor memory, so you could put a cursor overlay on top of your graphics. And the graphics look pretty good. Can you hear me?
Hey Rob, yeah, you can. So
yeah.
Scott's having
exactly. Oh, Scott's having issues too. Damn. Okay, so let's go to what the hardware looks like. So right now, in our parts, we have GPUs, and we're using, on the lower end stuff, we're using vector graphics GPUs, and they support VG Lite or OpenVG, and they take care of all the rendering. And then we have display controllers that take care of some of the compositioning. So but that boundary is fuzzy. There's some of it happens, some of the compositioning happens within the GPU, some can happen within the display controllers. And you know, we call, I kind of mix the words up a little bit, but we have a thing called a PXP, which is a pixel processing engine that does layering and some other ideas. So that can do the compositioning, whereas the GPUs can just do the path and draw lines and things like that. And it can apply textures. And then the display controllers then can do the blending. So there's a bit of a fuzzy boundary there, and that kind of makes it more complicated. And then the display controllers, the display interfaces, I should say, not display controllers, they take care of the rastering. So they can raster out of memory. And so that display controller can be either RGB or MIPI, like I said before, or other interfaces. We have within our parts, we have something called Flex IO, where we can use that to interface with any kind of parallel or even serial display, because we're seeing different LCD vendors have different interface requirements that aren't really standard, that don't follow a MIPI like DBI, or they don't have that kind of thought in their heads, I guess. So we can apply this Flex IO and have any kind of display interface we want. So again, we have the hardware composed of GPUs, controllers, and then display interface. So for the best, I just want to give a summary of that. We have RT500. Oh, we're going really fast here. RT500, which uses a VeriSilicon GC Nano Lite that supports open, and then 1170 is a VeriSilicon GC355, which supports OpenVG.1. And then the controllers, RT500, it's a GC Nano Lite, which supports dithering and some gamma correction, and also has cursor memory. It has a PXP engine that does blending, as well as some compositioning, rotation, and things like that. That's earlier, is having a course that understands the hardware and how to take advantage of those two things. It's really important to kind of figure out how to rendering and where to do the comp more efficient way, and also you can get better performance boosts. We've seen using both engines, like the PXP and the 1170, we can build the frame rates by using those. So that's another way that you have to really understand how to use those things. And I talked about the display control already with MIPI. We support DBI and DPI on those guys. And we also have this programmable interface. Okay, then the next thing I wanted to talk about was this idea of memory. So, and the graphics subsystems. So the graphics hardware are complex, and they need to have access to memory effectively. So on the RT500, we have three major compute elements. We have an N33 that has access to a full 5 megabytes of unified memory, as well as a Fusion DSP. Then we have the GPU that can have allocations in 5 megabytes of memory. And there's two external memory interfaces. They're called flex PHYs. So we can attach to either NV, quad PHY flashes, or PSRAMs through those two interfaces. So you have a significant amount of resources for your frame buffers. Things can be, depending on the size of your display, you can use external memories for bigger displays, or only internal memories for smaller, like they say 400 by 400 kind of wearable displays, where you don't need to have that much memory for frame buffers. But this architecture allows you to have not just internal memory, but also large external memories. So it's kind of almost unlimited resources. Then the RT10 series, we have the same kind of approach, where we have an LCD controller, and it has access to significant external memory resources. They could be external parallel memories, or they can be external quad or octal SPI flashes. So again, it's not just about the graphics components that you have, it's also about having a significant amount of memory resources that have really low latency and single cycle access for the GPUs and other graphic elements like the display controllers, so that they have seamless interfacing to those memories, so you can get high throughput to have really good and smooth graphics. So again, I think the most important thing here is that we have good partners, and partners like Crank are really important for effectively using our hardware. And I think that's my last slide.
Perfect. So with that, I'm just going to pass over things to Jason. Give him control there. Thank you, Rob.
Thanks. All right, show my screen. Sent. Hopefully everybody can hear me fine. Jason Clark, I'm the VP of Marketing, and I'm one of the coaches here at Crank Software. Pretty excited to talk about how we take the products and customers come to life, and it's a really exciting area of what's happening in the market. So we'll talk through that. So just quickly, software, if you're not familiar with us, graphics company on many years of embedded engineering, and we are built ground up for the embedded market. We are not a when we build Crank, Storyboard product and everything like that, it's totally for the market. We are and lately we've been winning a lot from industry, our partners, press, all the exciting things we're doing inside of the areas inside of how to take advantage of all the power that NXP are providing. So if you're not familiar with Crank, you may with us. We're dual customers around the world. Touchscreens you're touching every. This is really what we focus. How to help these customers bring these rich interfaces to life. So they have graphics design teams, marketing teams, everybody coming up with new concepts, ideas for new products, whether in sort of our standard market we've had for a long time, new markets such as wearables and the IoT edge devices and stuff like that. A lot of interesting stuff going on, and we're running across all of these different. It's because when you think about it, they're all having this issue. They all need to be able to bring their stuff to. They need to bring this rich user interface to life as best they can, and it's not a unique problem. Before it used to be industrial and medical devices, they had this very archaic look, but now everybody wants to chase the feeling they have on the iPhone or their Android phones or whatever. That experience is expected. When a customer touches a touch screen, they come in with an expectation that it's going to have a feel, it's going to scroll, it's going to do different things, and they don't have context awareness of the type of hardware that's underneath there, or the price points, or all the technical considerations you guys had to make. So it's probably not a fair assumption, but it's one we have to live with. So that's where we're going to talk about today. So Crank Software, the company, we have support and we have product and services to help you do all these things, but our flagship product is our Storyboard development environment. So this is a development environment that makes it faster and easier for design teams and engineering teams to work together to create a vision of a rich user interface on an embedded device. So this is where we focus, this is where we spend our time, and this is what we like doing. So we love to take things like how Rob was talking about, all the hardware that they're presenting to us and all of these advantages, and make them available to our customers in a nice, easy fashion. So Storyboard is our development environment. It runs on Mac, Linux, and Windows. It can develop across multiple different backends. It has a lot of pieces to develop for MCUs all the way up to MPUs, so we can go right from the bottom of the RT series and even some of their older platforms, the LPC series too, all the way up to their most complex multi-core, multi-GPU systems, and leverage either whatever backends behind it. So, and where we really focus with Storyboard is making it so the design team and the engineering team can work in parallel to drive the UI faster and better to end product. So taking what Rob talked about there in the market, there's a lot of stuff happening inside of there. And as I said, when a customer touches a touchscreen or touches glass, there's an expectation immediately, and the consumer products are feeling it more now than ever. there's an experience set out right from the beginning that they're trying to match that cell phone experience, all those rich interfaces they've touched before. But if I'm making a coffee machine or something like that, I may not be able to put that giant GPU on there to give that same experience. It's not a fair comparison to compare my cell phone processor and memory and requirements that they were able to use to leverage that experience when I'm making a very cost-effective price. So that's where we come in to take advantage of all these little advantages that our hardware vendors are giving us. So the hardware technology is constantly evolving, so new stuff's coming out. You're getting more, but with more, with great power comes great responsibility, but it comes more work. So how do I take advantage of it as well? And the other issue that's coming is it's such a competitive market that the product timelines are shortening very quickly. So, people are trying to get to market as fast as they can. So it's a perfect storm there, high expectations, evolving hardware, and short timelines. So this is just making a great spot for, there's great opportunity, but there's hard work that has to come with it. And how can we make that easier and better for our customers is really the big question, So I thought today I'd talk about a customer story that we just released in the last month or so with one of our customers that is one of these devices. And so when I was thinking about what to talk about here, I thought, this is just a great opportunity because Dometic, which is a company that's really focused on making outdoor living easier, I believe is one of their taglines, or they do so much in the outdoor living space with coolers, camping, RVs, everything like that. They were coming into a new marketplace with this new device that they chose Storyboard on top of the NXP RT series, and they got to market in record time. So I'll talk through some of the quotes they talk about, and the customer story is on our website. So if you want to go check it out later,